In this video, we're still working on topic 2.3. We're going to look through explain 1 parts A and B. So you can use the transformation of function, the graph of a basic function called a parent function. So any function, the basic function, the most basic of it is always called the parent function. To obtain the graph of a related function, to do so, focus on how the transformations affect reference points on the graph of the parent function. For instance, the parent function quadratic function is f of x equals x squared. The graph of this function is a U-shaped curve called a parabola with a turning point called a vertex at 0, 0. The vertex is usually the reference point, as are the points -1, 1, and 1, 1, and 1, 1. So this is your vertex right here, and these are some very easy reference points to find is what that's saying. And again, the U-shape means parabola. So there isn't a whole lot you're going to write down in example 1A. I didn't delete the stuff for you, so it's all there. So we're just going to kind of talk through it. So we're supposed to describe how we would transform the graph to obtain the related function. Then we're going to draw the graph. So first of all, we look at the value in front. That's our A value. So our A value is a -3, which means we have a vertical stretch by a factor of 3. It is negative, so that negative makes it a reflection in the x-axis. We'll notice that there's nothing in front of the x on the inside, so that's b equal to 1, so there's no horizontal stretch or compression. H equals 2, this is the h value in there, but notice it's a positive, or it's negative inside there, which means it goes in the positive direction, so it's going to go to the right 2 units. We use the word translation, technically horizontal, but if you use the word right, that implies horizontal. K, notice, is -4. That's always at the end there. So -4 is a vertical translation, and it's going to go down 4 units. Okay. So applying these transformations to a point on the parent graph results in this function right here. The table shows what happens to the 3 reference points of the graph. So what they basically did was they said that we're going to add 2 to the x. Okay. And then we're going to multiply the y by -3 and then subtract 4. So when I add 2 to the -1, I got 1. And then when I multiply by 3 and subtract 4, I get -7 of the 1. 0, 0, I add 2, I get 2. I multiply -3 by 0 and subtract 4, I get -4. Now I'm plugging in 1, 1. So I plug 1 in. 1 plus 2 is 3, and then -3 times 1 minus 4 is -7. Then they simply took these points and plotted them there. Okay. All right. So on this one here, the parameters, we're going to look for the parameters. So notice there's nothing written in front of the f of x, so that means it's 1. So since A equals 1, there's no vertical stretch or vertical compression. You'll notice that there is a 1/2 in here. So the parent graph is stretched, right? It's a stretch this time. Horizontally. Okay, so stretched horizontally. Remember, it's a factor of whatever's in here. So whatever the denominator is. There is no reflection in the y-axis. There's no reflection because there's no negative. The parent graph, I always go opposite my sign. So -5. Parent graph is translated -5 units horizontally this time. K is keep the sign the same for K. So 2. Translated 2 units vertically because it's on the outside. All right, so what's going on here? So this time, because the factor is on the b, that means I multiply this number by the x, and then I have to apply the h value to it, so -5. And then the y, I didn't do anything with the a, but I have to add 2 to the y. Okay, so that's where we're getting this formula from. So when I do 2 times -1 for the x minus 5, I end up with -7. When I do 1 plus 2, I get 3. When I do 2 times 0 minus 5, and again, I'm getting these values from here, I end up with -5, and then 0 plus 2 is 2. 2 times 1 minus 5 is negative 3, and then 1 plus 2 is 3. And I'm going to plot those values. So negative 7, positive 3, negative 5, positive 2, and then 3, positive 3.